Children, class 9 CBSE board, welcome in my channel CHAP-7 Physics. Already you know that I have started a channel for foundation level physics and chemistry syllabus, so that you will be benefited when you are appearing for any competitive exam near future. So today my topic is motion, that is included chapter number 7 NCERT book, physics part, motion and rest. Motion is relative. Define displacement, distance, speed, velocity, acceleration, retardation, proof v equal to u plus at, and average velocity. These are the subtopics I am discussing one by one. My target is that this chapter again will be repeated in class 11. So if you are little bit accustomed or little bit your basic conception or basic idea or basic information is clear in class 9, then I think you do more trace on numericals in class 11. So I am first question, what is rest? And question number 2A and B is what is motion? In brief, what is motion? And different type motion one by one I am discussing. What is rest? First thing, whatever you observe in front of you, either the body is at rest or is in motion. As for example, bird flying, that is bird is in motion, train running, that is train is in motion, but I am standing on a platform, I am rest. So rest means the body does not change its position with respect to time. Rest means no change of position. Rest means no change of position with respect to time. If position changes, then I say that body is in motion. Clear? But it is why relative? Question is why relative? Answer I am telling you why it is relative. Question number 3, why it is relative? Because a body which you observe rest, you are observing with respect to you or with respect to time, it is not changing its position. But if the same body observed from the running body, there is a relative motion. Suppose a man standing on a platform, a train moving. So a passenger inside the train will see that rest body on platform running behind. That means if you change the rest body, if you see the rest body from the running condition, then you will see they are in motion. As for example, you see a tree as rest when you are standing, but if you move in a bus and from the running bus you observe the tree, then tree is in motion. So whether the body is rest or motion, that depends on where from you are observing or which reference frame you are observing. As for example, I am told you that from running bus, if you observe a passenger standing on a platform, that passenger inside the train will see the passenger also, passenger standing on the platform also running with the train in opposite direction. This because you are observing the passenger from inside the train. Now both are rest. If train is rest and the passenger on the platform is rest, then both are rest. So but if one is motion, other is rest, or if there is a relative motion, then one's body will see there is a relative motion of the second one. Clear? So again I am repeating, motion is change of positions with respect to time, and rest means no change of position with respect to time and with respect to observer. So this is the condition, motion and rest. Now motion is relative, already I have told where from you are observing. If both there is a relative motion, then the second body will be is in motion, although it is rest, but from that point of view second body will be in motion. Clear? Next I am going to define different important terms regarding displacement, distance, speed, velocity, acceleration, retardation. These 6 terms, 1, 2, 3, 4, 5, very important, because what is displacement? Suppose a body a body is moving at the point B. Now I should say shortest distance between A and B, that is the displacement in a particular direction. Shortest distance, that is vector. Displacement is the vector. Clear? Is a vector. That is the shortest distance A to B. But path followed by the particle AEFG AB, there is a total path covered by the particle. That is distance. It is a scalar quantity, distance. So total path covered by the particle, that is distance, and shortest distance between A and B, that is the displacement. Now displacement per unit time is velocity, and speed equal to distance by time. Since speed cannot be negative, because distance cannot be negative, speed cannot be negative, displacement can be negative and positive both. So velocity can be both positive and negative. Now my question is, I think it is clear that, again I am telling you that what you are observing here, that displacement and distance both are negative and positive. Speed cannot be negative, but displacement can be negative and positive both. Clear? Displacement can be negative, positive both because it is vector, but speed cannot be negative. Clear? Now if a motion is in straight line, suppose it is straight line, A to B is a straight line, then displacement equal to distance. So numerically velocity equal to speed maybe, but maximum cases displacement less than distance. Clear? Displacement in curved path, a part in a graph. Later on I am showing you in my second lecture. In graph it is clear. In graph, suppose your graph, you see that wherever you are changing, suppose you are in a graph, you see there is no graph in motion where a particle can occupy two different displacement or different positions in a single time. Even particle cannot occupy two different velocity at the same point. So this is the case, and unit of both are same, that is meter per second. It is also unit is meter per second. SI unit I am telling certainly. So now again I am telling, a moving particle going from A to B, then shortest distance in a particular direction, that is displacement. In curved path when it is moving, always displacement less than distance. After that I have told displacement calculated by unit time, that is velocity, that is vector quantity. I have told you that this velocity cannot take two different positions, two different values at the same time. Speed cannot be negative. Clear? After that, what I am telling you, let us see what is acceleration. Now you see, by graph I am showing you, if you take, this is the time, you divide this time into three different parts, t1, t2 and t3, and that is the velocity. Along the y-axis you take velocity, along the x-axis you take time. Now first from the starting point, this 0 to A, then A to B, then B to C. This velocity is V maximum. Suppose 10. What does it mean? If the particle moves with an uniform change of velocity, suppose 10, then 12, then 14, then 15 meter per second, then we see velocity gradually increases at uniform rate. Velocity increases at uniform rate. Clear? That means in that case I should say particle moving with acceleration 10, 12, then it is 16, 10, 12, 14, 16. Also 2 meter, velocity increases by 2 meter per second. So acceleration equal to A equal to velocity change by time. That means 2 meter per second by second. That means you are getting 2 meter second square. So rate of change of velocity, that means velocity change per unit time, that is the acceleration. If velocity changes at uniform rate, then it is uniform acceleration. If non-uniform rate, then non-uniform acceleration. As for example, OA represent accelerated motion. OA represent accelerated motion. Now after that, if velocity remains constant for time t1 to t, suppose time t1, here t1, it is t2 and it is t3. So I should say after t1 for AB, uniform velocity, at uniform velocity. That means for time t1 to t2, uniform velocity. For time t1 to t2, uniform velocity. After that I see that velocity gradually decreases. Velocity from T2 to T3, velocity gradually decreases. Velocity decreases at uniform rate. That is called retardation. That is called retardation or negative acceleration. That is also A. Retardation means gradually velocity decreases at uniform rate, and acceleration means gradual increase at the uniform rate, increase of velocity. So retardation I am showing you. Suppose 18, then 16, then 14, then 12, then 10, then 8, 6, 4, 2, 0. So you see velocity decreases. Then velocity decreases at uniform rate. Velocity decreases at uniform rate. That is retardation. Clear? Again I am repeating. Retardation. Unit is same. So in this graph, first OA accelerated motion, acceleration positive, then V constant, then V negative, then retardation negative. So in that case it observed for T1 gradual velocity increases, then velocity constant for a time T, and then velocity gradually decreases, the retarded motion. That is the mixed. First acceleration, then uniform, then retardation. So in your examination paper this definition may come. Now there is no motion, remember always there is no motion where displacement is more than distance. There is no motion where distance is negative and speed is negative. But at a single point a particle cannot occupy two defined positions and at the two defined velocities. So already we have discussed. Now what the motion means? Change of position of the body. Rest means no change of position of the body with respect to time and observer. Motion is relative because that means motion is explained with respect to another frame of reference, whether it is motion or rest. On this basis the second body is in motion or rest. As for example, I told you, if you see a tree rest with respect to earth, but if you observe from the other planet, the same tree is moving with earth, that means from moving system you observe in the tree, that is in motion. Now define the displacement. Already I told, for a moving particle A to B, shortest distance, that is the displacement, that is vector, and total path covered by the body is the distance. When you are going to calculate velocity, what will you do? First calculate the displacement and divide it by time, and per unit time displacement, that is the velocity. Per unit time distance is speed. Speed is a scalar quantity and velocity is a vector quantity. If there is a gradual increase of velocity, then we should say body is moving with acceleration. If body gradually decreases velocity at uniform rate, that body moving with uniform retardation. So I have discussed displacement, distance, speed, velocity, acceleration, retardation. Now I am going to derive the formula number 1, that is the equation number 1 for motion. So I am deriving initial velocity. Suppose initial velocity u, final velocity is v, time t. You know acceleration A equal to what? Change in velocity, final minus initial, change in velocity by time. Then you are getting A equal to v minus u by t, or you are getting cross multiply v equal to u plus at. If the body starts from rest, then u equal to 0. Clear? Then u equal to 0. Now if the body moves under gravity, if the body moves under gravity, you take A equal to g, that is equal to 10 meter per second square if nothing is given. If nothing given, A, g or 9.8 meter per second square. Clear? So against gravity it will be minus 10, in favor of gravity it will be plus 10. So if body comes to rest, if the body stops, then v equal to 0. If the body stops